Okay, so I'm going to demonstrate how IPv6 anycast can be used to provide extra redundancy in a distributed system, as well as provide transparency for the clients as they connect to that distributed system. And basically what we did is we took our program assignment number 4 and stuck it into an IPv6 environment, and then we'll demonstrate how well that works um, using the IPv6 anycast kind of technology there. Now what we're looking at right now is actually the topology of the little network, simulated network that I've got set up. The program I'm using is called GNS3, and it's basically a network simulator. And these routers, R1, R3, R4, and R5, they're actually emulators that run the Cisco software on that runs on Cisco routers. And so what I've done is configured each of these routers interfaces with an IPv6 address, and then on these two interfaces, F20 and F11 here, I configured them to have an IPv6 anycast route, and so they share the identical IPv6 route, and then I'm using OSPF to route between the 4 routers. And so what will happen is and then what I did is these two computers here, the QEMU emulated hosts here, those are the 2 servers, and I've configured each of those servers with an IPv6 anycast address, and they've got the same IPv6 anycast address. And then these are the clients on the left side here that will communicate with them. So what will happen is QEMU1, for example, will send a packet, a request, or a database update or whatever to that IPv6 anycast address, and it will be routed through this network to this QEMU2 host, and then that database will be updated. And then these 2 servers, of course, are connected in the network as well, and they update the database concurrently. So when QEMU4 here sends a packet, it will actually go to this route and make a database change to this guy's database. And that's because the number of hops to this IPv6 anycast address is less than the number of hops here. But of course, if this link were to go down, for example, then when this host sends a packet, it will actually be routed correctly to the other IPv6 address. And so we'll go ahead and demonstrate that. So if we go ahead and pull up our servers, so the servers we've got running is QEMU3, and this terminal here at the top left is just giving you the feedback. That's the actual server running. It's kind of giving feedback about the status of the other server, as well as kind of this timestamp stuff. And then if you look at the ifconfig output that I've got pulled up here, you can see that this has got some special 4 different IPv6 addresses here. This one I've got highlighted as the actual IPv6 anycast address, and then it's got some other ones, like this one is the actual link local IP address, and this is the global IP address, and these are because not only do we have the IPv6 route configured, anycast route configured on the routers, but they also have their normal routes, and so that's getting that IPv6 address from the router, and it's also getting this IPv6 address from the router just as a side effect of the of its routing the IPv6 anycast network. And then with Java RMI, in order to provide RMI on a routed network, Java uses a protocol called IIOP, and there's a special property that you have to set in order to get that to work right, and that's this java.rmi.server.hostname property, and you can stack those. And so this server essentially is listening for requests using this IPv6 anycast address as well as its normal IPv6 address. And so if we go ahead and pull up the other server, just notice it's pretty much configured the exact same. It's just got a different IP address, but you can see that in this ifconfig that I've got tucked away here, it's got the same IPv6 anycast address as well. So what we want to do is go ahead and pull up the clients now, and this is QEMU1. We'll go ahead and run the script that we've got set up to run the database request. And so basically this is the IPv6 anycast network that we're connecting to. I've got it kind of in a host name, but if you look at the host files, you see that's the IPv6 anycast address there with the friendly name running on port 9999. Now the other client is configured exactly the same way. And so if we run the little script here, it'll fire off that execution. And I've got the network slowed way down just so that we can see the traffic go through, so that I can have time to pull up these servers here. And so if we pull up both these servers, as they kind of go on, eventually we'll see, there we go, requests from the client. So it's calling create user, and that request is going to QEMU2, and then if you look here, this query insert thing, that's actually just the server syncing up, basically sending the request using the vector time clocks as a timer to update the databases so that they're both concurrent. And so QEMU1, of course, sent the packet, and QEMU2 received it, and that makes sense if we look at our network again. And then if we pull up that other host, QEMU4, and basically fire off the same script, it'll send that packet over the network, and we can pull up the servers again. We can watch those go through. Actually, the reason why it's so slow is just because the simulated network is just that, emulated, and it's not very fast at all. So we'll give it a second to get its connection through. So you see the QEMU3 is the one that actually received the request that time, and then it synchronized with the other database through the network. So that makes sense. QEMU4 sent the request to QEMU3. And so it works quite well, even though the clients are sending to the exact same IP address. The network gets kind of load balanced and distributed based off of the distance. Of course, it also has the built-in redundancy, and so we can go ahead and demonstrate that real quick. If we pull up the configurations to this router 3, which I've got right here, we can actually configure that specific interface to be down, and then that means that it's like simulating the route being down. So I'll go ahead and set that up real quick by going into the interface and configuring that, just by telling it to be shut down, basically. And so now that the route's been shut down, there's no more route to that host. And so we go ahead and pull up this other client, QEMU1, and we'll fire off the same script. And then we'll look at our servers and see where the request comes through at. Just wait for it. So this guy's complaining that he wasn't unable to sync up with the other server, but this is QEMU3, and it says that the create user was created successfully. So what we've got is QEMU1 sending the packet, and it's actually getting routed to QEMU3, even though I didn't change anything at all. And so with this demonstration, it's easy to see how IPv6 can be pretty beneficial in a distributed system, kind of simplifying the distributed part of it by using IPv6 anycast to provide transparency and the extra redundancy on the network. So thank you very much.